Hello friends and welcome back. So today's topic for discussion is virtualization and different ways and methods of virtualization and how they are transforming the way we utilize computing power. So without wasting any time, grab a notepad and let's begin. Virtual means nothing real. Simply put, virtualization is the creation of a virtual version of something that typically exists physically, right? In computing, this means creating a virtual environment for hardware, storage, or even entire operating systems. Virtualization enables us to do more with less hardware, right? For example, imagine you have a single physical hard drive, but you want to partition it into two separate drives. Through virtualization, you can create two virtual hard drives from one physical drive. Though the hard drive is a single unit, it's digitally separated into two distinct entities, right? What are some different methods or ways of virtualization? So there are several types of virtualization, each serving different purposes. We will break down the different types of virtualization like operating system virtualization, application virtualization, application server virtualization, management and administration virtualization, network virtualization, hardware virtualization, and storage virtualization. So let's discuss each one by one. What is operating system virtualization? Operating system virtualization allows multiple operating systems to run on a single physical machine simultaneously. This is achieved through virtual machines, each acting as a separate computing environment. For example, like running both Windows and Linux on the same computer. Developers can test their applications on different operating systems without needing separate physical machines, right? Why operating system virtualization is used? Resource efficiency reduces the need for multiple physical machines, saving on hardware cost, energy consumption, and space. Provides isolation. Each virtual machine operates in its own isolated environment, preventing issues in one from affecting others, right? It offers flexibility, which allows users to run different operating systems on the same hardware, useful for testing, development, and running incompatible softwares. Next is application virtualization. Application virtualization separates applications from the underlying hardware and operating system. The application itself is stored on the central server, but users interact with it seamlessly on their local machines. For example, an organization needs to deploy a specific design software to all its employees. Traditionally, they would install the software on each machine individually. Application virtualization eliminates this process. The application is managed centrally on the server, simplifying deployments and updates. Employees can access the software from any authorized device, which enhances flexibility, right? Why application virtualization is used? To deploy applications centrally to a server, eliminating the need for installation on individual machines. It ensures users have the same application version and configuration, improving consistency and security. And easier updates are deployed to the central server, automatically rolling out to all users. And these applications don't need to be installed locally, freeing up disk space on user machines. Next is application server virtualization. It is also known as advanced load balancing. This involves dividing a physical server into smaller virtual servers, which allows for easier management of resources and applications, as everything can be managed from a single instance, right? How application server virtualization achieves load balancing. Application server virtualization creates multiple copies of the application server software on the same physical server and uses a load balancing algorithm to determine which application server instance should handle each incoming request. So, how it works? Suppose a customer tries to access the e-commerce website. The request goes through the application server virtualization layer, which checks the current load on each application server instance like CPU uses, memory availability. Based on the load balancing algorithm, the application server virtualization routes the request to the most suitable application server instance. And the chosen application server instance processes the request, retrieves the product information, and displays the shopping cart or handles any other customer interaction. This way, the response is sent back to customer's browser. Why application server virtualization is used? It provides improved scalability, easily add or remove application server instances as needed to handle fluctuating application traffic, enhanced high availability. If one application server instance fails, it can automatically redirect requests to another instance, minimizing downtime. Streamlined application management helps in managing all application server instances from a central location. Efficient resource utilization. Distribute application workload across multiple instances, preventing resource overload on any single server. Next is management administration virtualization. It is a type of virtualization that focuses on separating and segmenting administrative roles through user policies or groups. For example, a large company has separate IT team for development, testing, and production environments. Management virtualization allows them to assign specific access privileges to each team, right? The development team can manage their virtual development servers while the production team focuses on critical production environment, all within a secured, controlled framework, right? Why it's used? It provides enhanced security. Granular control over administrative access reduces the risk of unauthorized changes or security breaches. Improved efficiency. It streamlines IT workflows by assigning specific management tasks to designated people. Reduced errors. Minimizes the risk of accidental configuration changes by restricting access based on roles. So it helps in implementing role-based access control, which ensures only authorized people have access to certain resources, right? I have discussed more in details about mandatory access control, role-based access control, and discretionary access control in my earlier video, which you can go and watch for better understanding. Next is network virtualization. It creates a virtual version of network resources on top of the physical network infrastructure. This virtual network allows for independent management and configuration and separates from the underlying hardware. It involves virtually managing IPs and is accomplished through tools like routing tables, NICs, switches, and virtual lanes. NIC stands for Network Interface Card. It is a wired or wireless adapter that allows the device to communicate with the network, right? Cloud service provider uses network virtualization to manage and allocate network resources to different customers. By virtualizing network components, the provider can quickly adjust bandwidth, assign IP addresses, and configure virtual networks for new customers without physical changes to the hardware infrastructure, right? And why it is used? Increased network agility. Provision and manage network resources like switches and routers more easily, adapting to changing business needs. Improves scalability. Easily expand or contract the virtual network as needed to accommodate network traffic fluctuations. Enhanced security. Create isolated virtual networks for different departments or security zones, improving data security. Next is hardware virtualization. It involves creating a virtual version of physical hardware. This can include virtualizing CPUs, memories, and other hardware components, allowing multiple operating systems and applications to run on a single physical machine. For example, a software development company uses hardware virtualization to run multiple development and testing environments on a single server. Each environment runs on its own virtual machine, allowing developers to test different configurations and applications without interference from other projects, right? Hardware virtualization is often already present on modern server hardware, allowing hypervisors to function. So, hypervisor is a software that manages virtual machines. In our upcoming videos, we will discuss about the role of hypervisor in detail and its type, so stay tuned. So another method is storage virtualization. Storage virtualization involves pooling physical storage from multiple devices into a single virtual storage system. This unified storage space can then be managed and accessed as if it were a single device. A data center employs storage virtualization to manage its extensive storage resources. By virtualizing storage, the data center can easily allocate storage to different departments as needed, move data seamlessly between devices, and scale up storage capacity without disrupting operations, right? It is used to manage storage centrally, eliminating the need to configure individual storage devices, allocating storage resources dynamically based on needs, reducing storage wastage. Storage virtualization is also used in disaster recovery. It replicates storage across different locations for faster data recovery in case of outages, and improved scalability. Easily expands storage capacity by adding new physical devices to the pool, right? So these were some of the methods or ways of virtualization. In our upcoming videos, we will discuss more in details about virtual machines and how they are used in cloud, what is a hypervisor, its type, and some security issues related to it. In our previous videos, we discussed about cloud deployment models and different cloud service models, which you can go and watch for better understanding about cloud. So stay tuned for regular updates. See you soon with another topic, another video. Till then, take care. Bye-bye. Consider joining me on LinkedIn.